So far in this module, you learned about views and inline table valued functions, how to create them and how to use them. In this lesson, you will learn about derived tables and how to write queries that create and retrieve results from them, what the guidelines are for creating and using derived tables, how to use aliases for column names in derived tables, and how to pass arguments to them, and how to nest and reuse derived tables. Let's get started. Earlier in this course, you learned about subqueries, which are queries nested within another select statement. Like subqueries, you create derived tables in the from clause of an outer select statement. Unlike subqueries, you write derived tables using a named expression that is logically equivalent to a table and may be referenced as a table elsewhere in the outer query. And unlike views or inline table valued functions, derived tables are not stored in the database. They represent a virtual relational table. With the view approach, you need to predefine how the data will look like, create the view, and then use the view in your query. And if this is something you would be doing over and over again, this might make sense to just create a view. But if you need to create something on the fly, SQL Server gives you the ability to create derived tables and then use these derived tables within your query. In concept, this is similar to creating a temporary table and then using the temporary table in your query, but the approach is much simpler because it can all be done in one step. And when processing a derived table, the query is run against the underlying reference objects at runtime, unlike temporary tables where you have to first create the temporary table, then populate it, and then you'll be able to select the data from it. Derived tables allow you to write T-SQL statements that are more modular, helping you break down complex queries into more manageable parts. Using derived tables in your queries can also provide workarounds for some of the restrictions imposed by the logical order of query processing, such as the use of column aliases. To create a derived table, you need to write the inner query between parentheses followed by an as clause and a name for the derived table. And the scope of a derived table is the query in which it is defined, which means that a derived table is created at the time of execution of the outer query and goes out of scope when the outer query ends. And since derived tables are not stored in the database, no special security privileges are required to write queries using derived tables other than the rights to select from the source objects. And one thing to remember about derived tables is that there are no performance benefits or specific performance costs to using them. Now let's see some guidelines for derived tables. The nested select statement that defines the derived table must have an alias assigned to it. The outer query will use this alias in its select statement in much the same way you refer to an alias table joined in a from clause. And all the columns referenced in the derived table select clause should be assigned aliases. This is only a best practice, but it's not always required in T-SQL. Each alias must be unique within the expression. The column aliases may be declared in line with the columns or externally to the clause. And the select statement that defines the derived table expression may not use an order by clause unless it also includes a top operator or offset fetch clause or a for XML clause. As a result, there is no sort order provided by the derived tables, and you need to use the order by clause in the outer query to sort the results. A derived table may not be referred to multiple times within an outer query. If you need to manipulate the same results, you will need to define the derived table expression each time. The select statement that defines the derived table may be written to accept arguments in the form of local variables. If the select statement is embedded in a stored procedure, the arguments may be written as parameters for the procedure. Derived table expressions that are nested within an outer query can contain other derived table expressions. Nesting is permitted, but it is not recommended because it increases complexity and reduces the readability. Now that we have seen the syntax and the guidelines for derived tables, let's create a simple derived table. Let's open a new query and create a derived table to retrieve information about orders placed by distinct customers per year. First, let's build an inner query. And let's do a select, let's call the year function of the order date, and let's call it order year, the customer ID from sales.orders table, and let's call this inner query as derived year. Now let's build our outer query. Let's do a select order year and then count of distinct customer IDs from our derived table, group by order year. Now let's execute this query, and it displays the order year and the number of orders placed by distinct customers per year. The inner query builds a set of orders and places it into the derived table, and the outer query operates on the derived table and summarizes the results. And as you can see, we've used an alias name for the year of the order date in the inner query. There are two methods you can use to create aliases. Let's see what they are. The two methods to create aliases in derived tables are internal and external. The examples that you see here use the same query logic to contrast the use of internal and external column aliases, and the outer query refers to the columns defined in the inner derived table. In the first example, the aliases are defined inline in the select clause. In the second example, the columns are defined externally to the select statement with the derived table's alias. And when using external aliases, if the inner query is executed separately, the aliases will not be returned to the outer query. So, for ease of testing and readability, it is recommended that you use inline aliases rather than external aliases. Let's execute both these queries and see what the results will look like. Let's paste the query that we just saw with the external aliases and execute both the queries. And as you can see, the results are exactly the same. Now that we have seen how to use aliases in derived tables, let's see how to make them more flexible by passing arguments to them. Derived tables in SQL Server 2012 can accept arguments passed in from a calling routine such as a tsql batch, function, or a stored procedure. And these arguments can be variables that are declared in the same batch as the select statement, or parameters passed into a table-valued function or stored procedure. So, when creating a derived table, you can write them with local variables serving as placeholders in their code, and at runtime, these placeholders can be replaced with values supplied in the batch or with values passed as parameters to the stored procedures that invoke the query. This will allow your code to be reused more flexibly than rewriting the same query with different values each time. For example, in the query that you see here, a local variable marked with the @ symbol is declared for the employee ID. And then a value is assigned to this variable. Then the query accepts the employee ID variable and uses it in the derived table expression. Let's execute this query and see what the results will look like. Let's open a new query. Let's paste the query that we just saw and click on Execute. And it will give the order years and the distinct customer counts for the employee ID 9. Let's change the employee ID to 10 and see what the results will look like. Click on Execute, and it shows that there are no orders or customers for that employee ID. So, as you can see, you can reuse the same code to get the values required for each of the employees without writing a separate query. Now let's see how to nest the derived tables. Since a derived table is itself a complete query expression, it is possible for that query to refer to a derived table expression. This creates a nesting scenario. Although it is possible, it is not recommended because it is hard to maintain and hard to read. For example, In the query that you see here, one derived table is nested within another. Logically, the innermost query is processed first, returning the partial results of order year and the customer ID from sales orders table. Next, the middle query runs, grouping and aggregating the results into derived table 2. And finally, the outer query runs, filtering the output to see customer counts greater than 80. As you can see, it is possible to nest derived tables, but it does add complexity. While nesting derived tables is possible, references to the same derived table from multiple clauses of an outer query can be challenging. Since the table expression is defined in the from clause, subsequent phases of the query can see it, but it cannot be referenced elsewhere in the same from clause. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw. First, let's execute the innermost query. Click on Execute, and it will give you the order year and the customer ID from the sales orders table. Let's now execute the second innermost query. Hit on F5, and it will give you the summarized details of the order year and the customer counts. And when you execute the outer query, it looks for customer counts greater than 80, and it will only display 2007 and 2008. Let's execute this query, and as you can see, only those years that have customer counts greater than 80 are displayed here. When creating derived tables, you need to know that a derived table defined in a from clause may be referenced in a where clause, but not in a join in the same from clause that defines it. The derived table must be defined separately, and multiple copies of the code must be maintained. For an alternative approach that allows reuse without maintaining separate copies of the derived table definition, we need to use common table expressions. Let's learn about common table expressions in the next lesson.